All right, so here's the solution video for 8.2, the chain rule. Remember, we're going to be talking about an inner function and outer function. We need the derivative of the outer function with the original inner function back inside times the derivative of the original inner function. If we think of it in terms of f of g of x, the derivative of this would lead to the derivative of f, the outer function, g of x, the original inner function, and then times the derivative of g of x. All right, so number 2, I take the time to rewrite my cube root as the 1/3 power. I take the derivative of something to the 1/3 power, that's going to get me the 1/3 to the negative 2/3, my outer function, the 1/3 power, write my original inner function back inside, and then take the derivative of that original inner function, which would be 3. 1/3 and 3 are going to simplify into 1. 3x plus 2 to the negative 2/3 power is going to move that radical to the denominator, and I end up with 1 over the cube root of 3x plus 2 quantity squared. Number 4. Again, like we talked about in class, there is a shortcut that you can use when we have the derivative of the root, where you can immediately just take the derivative of what's inside the square root, that would be 6x minus 4, and put it over 2 root what had been in there originally, and then from there it would simplify into what I got as a final answer. Or if you prefer to go through the process, we rewrite our radical as something to the 1/2 power. The derivative of my outer function is 1/2 times the original inner function to the negative 1/2, and then I take the derivative of that original inner function. Since the 1/2 and the 6x minus 4 can reduce to 3x minus 2, I rewrite 3x minus 2 over square root of 3x squared minus 4x plus 9. Number 6, already set up with the fractional exponent, so I take the derivative of my outer function, 3/2 times the original inner function to the 1/2 power. I take the derivative of 5 minus 3x, which is negative 3x, and then negative 3 times 9/2, negative 3 times 3/2 gets me negative 9/2 square root 5 minus 3x. Again, in something like number 8, you could quickly use the shortcut that we discussed in class, where you take the derivative of what's inside your square root and put it over 2 radical what was originally there. This problem reduces, and so we'll see that the final answer, I take a 2 out of every term in the numerator. But again, if you prefer to go through the process, we rewrite our function to the 1/2 power. I know the derivative of something to the 1/2 power is 1/2 times that original internal function to the negative 1/2 power, and then I take the derivative of that internal function. And again, the 1/2, the 6, the 2, the negative 32 can reduce. Again, in number 10, you could use the shortcut again, where I know that I can take the derivative of what's inside my square root. And remember, we've defined this shortcut as for square roots, not for other roots. And I put that over 2 times the square root of the original function inside. Or, if you prefer, we can rewrite to the 1/2 power. My outer function is the 1/2 power, so I've got 1/2 times my original inner function to the negative 1/2. Take the derivative of that internal function, and then we end up with our final answer. Now, the shortcut that we've talked about does work in a problem like 17, where we've got a quotient rule situation, but for some people it can get a little messy when they see the fraction in the fraction and they have to use the reciprocal. So I recommend, when we have to do a quotient rule, using a square root to actually take the time to go through the steps. So I've got something to the 1/2 power. I use my power rule, outer function becomes negative 1/2 to the negative 1/2 with my original inner function back inside. And then when I take the derivative of my original inner function, I've got to use my quotient rule. So I've got low, d high, minus high, d low, all over low, low. Took care of simplifying my numerator there. Okay. Now, since this exponent is to the, since this exponent is to the negative 1/2, I can take the reciprocal of what's inside that parentheses. So I flip my 6x and x squared minus 9, making my exponent positive. Since x squared plus 9 is to the 1/2 power, and I've got x squared plus 9 squared, I can use my rule of exponents that would say I have 1/2 minus 2, which is going to lead to negative 3/2. Or in other words, that x squared plus 9 in the denominator with a positive 3/2. And then finally, I can simplify my 1/2. I can take 2 out of each of these terms, and that's how I end up with my, I lost a negative, pardon me, there should be a negative there. That's how I end up with my negative of negative 3x squared plus 27 all over 6x to the 1/2 x squared plus 9 to the 3/2. Of course, if you wanted to distribute this negative into the problem, you'd be more than welcome to. I wanted to make sure we saw 21 because we're going to see a lot, or you're going to see a lot of this when you're in calculus next year where you've got a polynomial raised to a power. So I've got my outer function, my inner function, take the derivative of my outer function with my original inner function back inside, take the derivative of my inner function, and although you could stop at this step, most people do tend to put the shorter polynomial first, but technically, mathematically, there's no justification for it. All right, multiple choice number 4. It's looking for the limit as x goes to infinity. This is just an end behavior problem. We've done end behavior problems before. So I need to focus on my lead terms as I always have, just recognizing that I would bring that square root with the 9x squared. Well, the square root of 9x squared is going to reduce to 3x. I can cancel my x's, and my end behavior, my limit at infinity, my horizontal asymptote, would be 3/4. And then finally, multiple choice number 5 is just trying to get you the idea of you can work with functions generically, like the idea that if I told you I had, let's say, g of x quantity squared and I wanted the derivative, well, I know how to take the derivative of my outer function, something squared. I know that I can represent the derivative of my inner function g as g prime, and even though I can't really do any more simplifying, I can at least set up the derivative. So I've got my outer function as h, my inner function is x squared minus 3. Even though I don't know what h is, I can represent its derivative with an h prime, the original inner function back inside, and then I take the derivative of that inner function, which would be 2x. The question's asking about f prime of 2, so I substitute in 2 wherever I see an x, and then I simplify. 2 squared minus 3 is going to give me h prime of 1, 2 times 2 is 4, and it looks like we have choice B. Again, I hope this helped. If it didn't, please feel free to ask questions. Never hesitate to bring things up that you still didn't understand from the homework, and we can answer them in class. Have a good day.